So another interesting, couple of interesting topics that we'll discuss today, because these these are the concepts which we generally use in our day-to-day life. Of course, not file transfer. We don't really use file transfer, but still, email is one thing that we use in our day-to-day life. We send and receive mails. A lot of communication happens through mails only, right? So that's our next chapter in Unit 5, email and file transfer. Email, we'll start with email. One of the most popular internet services is email, electronic mail. The designers of the internet probably never even imagined that the popularity of this application program would, it would just become like this. I don't know. You know the inventor of email? Do you at least know that he is an Indian? As far as my knowledge is concerned, the inventor of email, I mean, the first person who tried to do this concept, show this concept was Annadurai. According to my knowledge, I don't know if it is perfect or not. He's an Indian, Tamilian, exactly speaking. So I don't even think that even the inventors of this email concept thought that it would become so popular over the world. Even now, in the entire world today, a lot of communication happens through mails, especially professional communications. You take professional communications, all professional communications happen through emails only, right? So what we are going to do is its architecture. We are going to study about its architecture today. Its architecture consists of several components that we discuss in this chapter. It's very simple to understand, easy to understand. Just put some concentration and try to listen to what I'm saying, right? So what we are going to study today is topics discussed, the architecture of email, then the components of email like user agent, what is the use of user agent and why we need a user agent. Then we'll have a message transfer agent, what is the need of message transfer agent, and the protocol that implements message transfer called SMTP, Simple Mail Transfer Protocol. Then we will need a message access agent. Why we need a message access agent is also discussed. And then the protocols that help in implementation of message access called POP, Post Office Protocol, and IMAP, Internet Mail Access Protocol. The last one is not in the syllabus. Web-based mail is not in our syllabus. Only those four we'll be discussing, right? So let us just consider a very general scenario before we go to email. See the greatness of email is I don't even have to be connected to the internet all the time. The recipient of the email doesn't have to be connected to the internet all the time. I can find my free time to get connected to the internet and send a mail, and even don't even worry about whether the recipient is connected to the internet or not. Isn't it? Is it correct or not? Doesn't matter if the recipient is offline, doesn't care. Whenever I want to send an email, at that time I can get connected to the internet. I can simply send a mail. And that mail goes and stays somewhere. I don't know where it is actually. We will see in today's class where actually that mail stays, and then how exactly it goes to that person which it is intended to go to, and exactly at the time when the person gets connected to internet, and at the same time when the person opens his or her inbox. అప్పుడే ఎట్లా పోతుంది, అప్పటిదాకా ఎక్కడ ఉంటుంది, what happens, all this we'll be discussing today, right? So as a part of this, excuse me, yeah, it's fine, right? So as a part of this, we'll take 4 scenarios first to understand exactly today's implementation of email. Let us take 4 scenarios. Instead of talking about email, let us start talking about the postal system first. It becomes easy for you to understand. Let us assume that I want to send a letter, a letter here, not email, general mail. General mail is postal mail, a letter. I want to send a letter to Manoj. This is my intention. There is an apartment. I live in the 4th floor of apartment 404. My flat number is 404. This is not correct. Just giving you an example. Manoj also lives in the same apartment. His flat number is 203. Let us assume 404 203. Now, how exactly the communication happens between these 2 people in an apartment is at the bottom of the apartment or at some place in the apartment, there will be a shelf. Hope you're understanding. Can you see that diagram? Exactly in between, you have a box with shelves in it. Just like that, let us assume that there will be a shelf or a box or a place where there will be shelves. First row of the shelves will be first floor people. For first floor people, 101, 102, 103, 104, 105, 5. ఒక ఫ్లోర్ కి ఐదు ఉన్నాయి అనుకుందాం ఫ్లాట్స్. Second row of the shelves will be 201 blocks, 201, 202, 203, just like a cupboard, wardrobe with partitions in it. Third row will be third floor, fourth floor will be fourth floor, fifth row will be fifth floor. Can you assume what I'm saying? If you assume this, it becomes easy. Can you assume what I'm saying? Can you understand this? Someone has to reply to me.
Yes, sir.
Yes, right. So now, any communication between these apartment people, all those 5 floors into 5 flats, 25 families or 25 people, any communication between these two people, they have to drop a mail in that shelf. Where exactly in the shelf? Who is the recipient? If I am from 404 and Manoj is from 203, I want to send a letter to Manoj. I have to write it on a piece of paper or on a inland letter or a postcard, whatever is the policy, the protocol that the apartment is using. Drop it in 203's shelf. Manoj also stays in the apartment, picks it from his shelf, 203, and reads it. Right? So here, the commonality is both the sender and the recipient of the mail is residing in the same building, is residing in the same apartment. And that is the hard disk. That shelf is the disk or the space where the data is stored. The mail is stored. Sender sends a mail to that shelf of the recipient. Recipient receives it from that shelf of the recipient only. If Manoj wants to send me a mail, he should write it, but post it where? Let's put it where? In a shelf.
The same shelf.
In the shelf of the recipient. What is that? 404 shelf. Because I stay in 404. I have a shelf there. 404 shelf. Right? So here, in my first scenario of email, when this email was first introduced, when the sender and the receiver were both on the same system. They were both on the same system. Sender sends a message and it goes and stays in the hard disk or in the shelf or in the location that can be accessed by the receiver. నేను మనోజ్కి మెయిల్ పెడితే ఎక్కడ పెట్టిన 203లో పెట్టిన 203ని ఎవరు యాక్సెస్ చేస్తారు? ఓన్లీ మనోజ్, బికాస్ ఇట్ ఈస్ హిస్ షెల్ఫ్, హిస్ పోస్టల్ షెల్ఫ్, రైట్? సో ఇట్ ఈస్ పోస్టెడ్ టు దట్ memory unit where that can be accessed by the receiver. Receiver is also connected to the same computer at the same time. Both are connected, both are online, both are connected. Now receiver also will access that message that is intended to get received by him. Happy, this is fine, but there is something in between that blue annotated corner page, and both the sides should be using that called UA. What is UA? User agent. What is a user agent here? For example, say I have a person in my house who will bring the letters to me, or who will take the letters from my house to drop it in the shelves. నేను 10 లెటర్లు రాసిన ఇవాళ. I have to drop them in 10 different shelves because they are for 10 different people in the apartment. Who should do it? I have employed a person. మా ఇంట్లో ఉంటాడు. నేను ఎప్పుడు లెటర్లు రాసినా సరే he will take those letters from me. He will drop them in the respective shelves. ఎవరెవరికి 2 is the address. 2 is the address, recipient. So in that shelf, this letter is dropped. Similarly, this person also does something, not only dropping the letters in the shelves, while dropping the letters in the other shelves, ఎవరికైతే పోవాలో వాళ్ళ shelf లో పెడుతూ, at the same time, he will check my shelf. For what? For what? If any letters have come to me, this person is my agent, mail agent for this user. So that person is called user agent. Without a user agent, this procedure of sending and receiving mails, initiation cannot happen. So what is the user agent here? The mail program, the mail application. For example, say Gmail on your desktop or on your mobile. That is the user agent. Without that app on your phone, can you really send and receive a mail? Can you do it first step? Without that, can you do it? No. So the first step we need is, the first component we need is in an email is the user agent, right? But this scenario is very obsolete. When first Annadurai started this email, program, he tried it like this. But this is not the case. See how it evolves. Then comes the second scenario. So this is the first scenario I have explained. When the sender and receiver of an email are on the same system. Here, in my example, it is apartment, same apartment. We need only two user agents. Manoj ko user agent to saripotadi, naaku oka user agent to saripotadi. Ante evarintiki vallu. Whoever the sender's user agent and the receiver's user agent are the requirements when both people are on the same system. But that is not the scenario today. Still, now I come to the second scenario. Second scenario is, again, I am sending a letter to Manoj. I am sending a letter to Manoj. I am residing in an apartment in Warangal. Manoj is residing in an apartment in Hanamkonda. I am residing in an apartment in Warangal. Manoj is residing in an apartment in Hanamkonda. Now, we are on two different systems. In internet, we are on two different systems. Or in the general world, we are on two different buildings, two different apartments. Is that correct? Is that okay now? Is the example okay? Did I enhance it a little bit? Then I can speed it up. Are you understanding? Are you understanding?
Yes, sir.
Right, let's go ahead now. So now, again, na apartment lo kinda I'll have shelves. In his apartment, he will also have shelves. I don't know who else is residing in Manoj's apartment. I don't know who else is residing in my apartment. I'm least bothered. I am sending a message to Manoj. I am in this apartment. He is in that apartment over there in Hanamkonda. Now, what should happen first? Now, I will have a shelf down at the apartment where it has two pieces in it, two parts in it. One is the letters that are coming to me. Other shelf, in the same shelf, I have two parts now. My inbox and my, you are very good with emails. My inbox and my
Send box.
sent box, outbox, sent messages. I have two parts now. So inbox is for those mails that are coming to me. ఎక్కడెక్కడ నుంచో వస్తాయి ఎవరెవరో పంపిస్తారు కార్తీక్ ఒకటి పంపిస్తారు శ్రీజ ఒకటి పంపిస్తారు Sultan will send a mail, Anvesh will send a mail. They are all pulled up in the inbox, and whatever mails I am sending out, they will be pulled in the sent box, outbox. Now, who should bring the mails to me from my inbox to my house, and who should put my mails, నేను ఇంట్లో కొన్ని లెటర్లు రాస్తాను కదా 10 మందికి, who should take those letters and drop them in my outbox? Who should do it?
User agent.
Yes, I need user agent. Similarly, Manoj in Hanamkonda apartment, he also has that shelves of racks. Again, in his shelf of 203, he will have two parts, inbox, outbox. Now, who should do it for Manoj again? His letters should be dropped in the outbox. The letters that are coming to him should be brought from the inbox to him. Who should do it?
User
Again,
agent.
he needs to have a user agent. So, obviously, the initial program at both the ends, there has to be a user agent. Sare bhai, I have dropped all my letters in my outbox. Now, those letters should go to the inbox of the recipients. మేమిద్దరం ఒక దగ్గర లేం కదా, ఒక బిల్డింగ్ లో లేం కదా. Now we are not in the same apartment. One is in Warangal, one is in Hanamkonda. Now, who should do this? Postal department. There should be a person called MTA, postman, mail transfer agent, an agent who transfers the mail from source to destination, which is from the sender to the receiver. Angel postman. What is the role of the postman? That person is supposed to take the letter from the source to the destination, from to. Similarly, here we will have a mail transfer agent. A mail transfer agent will send this envelope or the letter or the mail, electronic mail, from the sender to the receiver or from the client to the server. So we will have two mail transfer agents, one on the sending side, one on the receiving side. Two MTAs, two user agents, two MTAs, mail transfer agents. Now see, look at the diagram. Alice is Sandeep, Bob is Manoj. Alice will use the user agent first and send mails into his outbox. From the outbox, there is an agent called mail transfer agent. The postman will pick those letters, send them over the internet, which is the roadway, railway, whatever way it is. send them over the internet. They get transmitted to the local post box of Manoj's place. Mail transfer agent again there. There will be a local postman again, or this same postman will drop it in the inbox of Manoj's apartment. So MTA to MTA, mail transfer agent to mail transfer agent, client to server. That is what will happen. Then from there, నా ఇన్బాక్స్ లో ఉన్నాయి, అక్కడ మనోజ్ ఇన్బాక్స్ లో ఉన్నాయి, అక్కడ నుంచి ఎవరు తీసుకొచ్చిస్తారు మనోజ్కి అగైన్? User agent. That is how the mail transfer happened in the second generation, second scenario. This is not done yet. Even in this second case, both the sender and receiver are connected to the internet all the time. But generally, is that our scenario in today's world? No. Let's go with the third scenario. This is the second scenario explanation. When the sender and receiver of an email are on different systems, two different apartments, we need two user agents and pair of or two MTAs, mail transfer agents called MTA client and MTA server. Right. Then comes the third scenario here. I'm not even in my apartment. I'm not even connected to the internet. Apartment we'll simply now come to internet, because if we keep continuing taking general examples, we will deviate from our actual concept. So I'm not even my device. I can use my laptop to send an email. I can use my mobile to send an email. I can use my daughter's iPad to send an email. I can use my wife's phone to send an email. I just have to log in with my ID, connected to the internet and log in with my ID. That device will become the sender of my mail, isn't it? So the Alice here, me, am connected to the internet or to the MTA, mail transfer agent, via LAN or WAN. I am connected to my router. In the local area network, I am connected to it. Now, first of all, until now, a connection to someone, what is the dashed line? What is the dashed line from me to mail server is, am I connected to the internet all the time? No, I may not be. Will I be able to send the mail? Yes, when you are connected to the internet. Very simple. Yes. So now, here, now whenever I want to send an email, I'll simply get connected to the internet. First of all, I have to take the help of user agent. I should first take the help of user agent in my local device. In my local device, I have to take the help of user agent. Now, I'm using Gmail. Now, Gmail will have a shelf created for me on the server. Gmail will have a shelf created for me on the server. Is that correct? Memory, location, unit, where all my data is stored. ఎక్కడ ఉన్నాయి నా ఇన్బాక్స్లో మెసేజెస్ అని నా ఫోన్లో ఉంటాయి, నా ల్యాప్టాప్లో ఉంటాయి ఎప్పటికీ. I'll just get them whenever I want, isn't it? Whenever I want, I'll just sign in and then I'll get that messages, right? So I have a memory unit created for me first, right? I have to send a message to that memory unit. From there, the data goes to the memory unit assigned to Manoj. From there, the data goes to Manoj's device whenever he is logged in. This is what will happen. First, from my device, the mail goes to my sent box, my outbox. From there, the mail, because my outbox can be n number of mails. I can send a single mail to 10 people. There will be 10 of mails in my outbox. From there, 10 different mails will be sent to 10 different recipients. Anlo Manoj okadu. The sent message will go to Manoj's inbox. Again, Manoj is also connected to Gmail. Manoj's inbox. Then from Manoj's inbox, it goes to Manoj whenever needed. This is the overall scenario. Send and gotangane poyindi anukuntam kada manam. You will still see how complicated or how good the architecture is. So now, first I need a user agent. Using a user agent, I get connected to the MTA server. So if I have to get connected to the MTA server, at my end, what should I first have? MTA client. MTA client. Why do I need a MTA client? Why do I need an MTA client every time? Because I've just told you, mail ID nade sandeep_ch@srec_varangal.ac.in. That is the same mail ID, but I can use that mail ID from my device. I can use the same mail ID to send a mail from my phone, my laptop, my daughter's iPhone. I'm changing the devices here to this. I'm not always connected to the same device, but still, I am sending the message from the same mail ID, from the same identity. Are you understanding that? So wherever or whichever device is being used, first it needs a user agent and then it needs a mail transfer agent at the same time. Then the first connection happens between where? From my device, because I'm composing the mail remotely on my device. Server lo compose chestanu anni on mail ni. Am I composing the mail on my device or on the server?
Our device.
On device. So using user agent, I am composing. Of course, I have that environment. I have that environment of composing, sending, receiving. User agent will help me. That is all the environment that I am receiving. That is user agent. But ఎప్పుడైతే నేను సెండ్ అని కొడతానో వాట్ షుడ్ హ్యాపెన్ వాట్ డిడ్ ఐ టెల్ యూ ఫస్ట్ ఇట్ గోస్ టు మై అవుట్ బాక్స్ ఐ హ్యావ్ టూ షెల్స్ ఫ్రమ్ దేర్ ఇట్ ఈస్ క్యారీడ్ టు ది ఇన్బాక్స్ ఆఫ్ రిసిపెంట్ మనోజ్ ఫ్రమ్ దేర్ ఇట్ గోస్ టు మనోజ్ డివైస్ అనగానే మళ్ళీ ఐ హ్యావ్ దిస్ క్వశ్చన్ హియర్ మనోజ్ విల్ హీ యాక్సెస్ ఫ్రమ్ ద సేమ్ డివైస్ ఆల్ ది టైమ్ may
No.
not but for now
No.
I'll assume that the recipient is using the same device always. That's why see there I am connected remotely but Manoj is directly connected always. Bob is directly connected there. This is the third scenario. So I'll enhance this in the fourth scenario. Bob will also be remotely connected, not online all the time, which is today's scenario. పంపించినప్పుడు వాళ్ళు ఆన్లైన్ లో ఉండొచ్చు ఉండకపోవచ్చు, వాళ్ళు ఎప్పుడు రిసీవ్ చేసుకుంటారో అప్పుడు నేను ఆన్లైన్ లో ఉండకపోవచ్చు. Doesn't matter, but still the communication happens. When I send a mail, a recipient need not be online. When a recipient receives a mail, sender need not be online, and still the communication happens. That's the greatness of email. That's why everybody is using it. Is it clear? Right? So now the first pair of MTAs is from my end to my sent box to the MTA server. From there, see in my left part of the diagram. From my MTA server, it is now using MTA client to send it again. So first transmission is happening from my device to my sent box, my outbox. Second transmission is from my outbox to Manoj's inbox. Did you follow this? Did you understand this?
Yes, sir.
Yes. So the first transmission happens between two MTA client and servers, which is my device to my outbox. Second transmission happens again between two MTA client and servers, which is a pair of MTA client and servers, which is my outbox to Manoj's inbox. From there again, Manoj needs a user agent to get it from his inbox. To get it from his inbox, Manoj needs a user agent. So how many do I need in this? How many user agents do I need? How many MTAs do I need in this scenario? Two user agents, which is at the sender side and the receiver side, one and one. One pair of MTA for first transmission. Another pair of MTA for the second transmission to the recipient, right? So here it is. When the sender is connected to the mail server via a LAN or WAN, we need two user agents and two pairs of MTAs. Now let's go to the last scenario, today's scenario, where the sender and receiver need not be connected to the internet at the same time. They can just have their time to get connected and send, and they can have their time to get connected and receive. Mail పంపించినప్పుడు ఆన్లైన్ లో ఉండాలని రూల్ ఏం లేదు, రైట్? సో దిస్ ఈస్ ది కేస్ నౌ. సో నౌ ఐ థింక్ యు ఆర్ completely aware of almost everything except one point. See logically how good this is. First, I'll use a user agent. Now I'm starting from the top left. I'm using a user agent. Why? Because I have to compose a mail. Not only composing, lot of things can be done by using user agent, but very simple example is composing. So I have composed the mail. Send. What will happen first? Someone who is listening, please answer me. What will happen first?
It is assigned to the client. MTA client.
Now when MTA client will come into picture, will play its role. So what will that MTA client do? It will connect to the Gmail server, to that place where my outbox is. So now transfer this composed mail. First step is transferring to Manoj Gadu, transferring it to my outbox, to the server first. So MTA client at my local site will transfer this mail to the MTA server, which is my outbox. From my outbox, there will be n number of mails that I am sending. Single mail lo compose lo nenu 10 20 50 mandi kudi vachada, right? So from that outbox, mail by mail, can you see a queue there in between the MTA server of my side to the MTA client on my side, in between black queue, a queue with black filled parts in it? So they are
Yes,
the mails.
Yes, sir.
Yeah, one after the other, each mail is processed at the server. Now again at this server, now again from my outbox, it should go to Manoj inbox, first mail, let us assume. Who should do this again? MTA again. Mail transfer agent. That is the role of mail transfer agent. Now that mail transfer agent will carry the mail from my outbox to Manoj inbox. Manoj inbox lo ippudu message undi. Manoj inbox, now I have a message. Now what do Manoj need? Does he simply need a user agent?
It has to bring from server.
So user agent guరించి మాట్లాడదామంటే now Manoj is not connected to the mail server. Manoj is offline. నువ్వు ఆఫ్లైన్ లో ఉండి జీమెయిల్ ఓపెన్ చేస్తే నీ కొత్త మెయిల్స్ అన్ని నీకు వస్తాయా? నో. మీ ఫోన్ లోనే you are using mails, right? You have Gmail logged in your phone. You are offline. You are not connected to the internet. You open Gmail. You really get all the new mails that were sent to you? No. Your user agent is working, right? Gmail open చేసినామంటే నీ యూజర్ ఏజెంట్ పనిచేస్తున్నట్టే కదా. It is working, right? Then why don't you get the new mails?
Not connected to server.
Not connected. So now this is the new thing that happens when the receiver comes. Receiver has to pull the messages. User agent has to pull the messages from the server. నా ఇన్బాక్స్ లోనే ఉన్నాయి, ఐ మీన్ మనోజ్ ఇన్బాక్స్ లోనే ఉన్నాయి, బట్ అక్కడ నుండి పుల్ చేసుకోవాలి. ఎప్పుడు పుల్ చేసుకోవాలి? వెన్ యూఆర్ కనెక్టెడ్ టు ది ఇంటర్నెట్. హూ విల్ పుల్ ఇట్? వీ నీడ్ ఏ న్యూ కాంపోనెంట్ కాల్డ్ MAA, not Movie Artists Association. This is mail access agent. The agent before was mail transfer agent. Now the agent is mail access agent. Manoj will now need a user agent and a mail access agent. Now the mail access agent will pull it from the server to the local client. Then Manoj will see his inbox. Then there will be a list of mails that the Manoj has received. UA, user agent, is displaying the mails. Did you understand how email works and what are the components that are associated in this journey of sending an email to receiving an email? Can I go ahead? Yes?
Yes.
Yes, sir.
Yeah, good, nice. So now this is the working. I did not even tell you the algorithms, I did not even tell you the protocols. This is the overall scenario of email works. So we now understood that for the actual scenario, today's scenario is fourth scenario. For this actual email scenario, today's scenario, how many user agents we need? 2 user agents, one at client, one at sender, one at receiver. How many mail transfer agents we need? 4, 2 clients, 2 servers. How many mail access agents we need? 2 mail access agents only at the receiving side. One is mail access agent client, mail access agent server. Okay, done. Now, what does a mail transfer agent do? Mail transfer agent client will always push the message to the server. It will push the message to the server. Whereas a mail access agent, client will pull the message from the server. Can you see it from the last diagram there? Can you look at the arrow marks? MTA client is always pushing to the server. MTA client is always pushing to the server. Whereas mail access agent, client is pulling it from the server. Reverse. Look at the arrow marks. Right? So MTA client is always push. It pushes the message from client to server. MAA agent will always pull the message from the server. Right. So when both sender and receiver connected to the mail via LAN or a WAN, we need 2 user agents, 2 pairs of mail transfer agents, and 1 pair of mail access agent. In red it is written. This is the most common situation today. Of course, it is the most common situation. So now let us start with user agent. I now have 3 components to discuss: user agent, mail transfer agent, mail access agent, and I also have to give you the structure of email. These 4 things will finish email. Right. So user agent, what is the user agent responsible for? What can you do if you log into Gmail? You can compose messages. You can read messages from your inbox. You can reply to messages. You can forward messages. You can handle your mailbox. You can change settings. You can do whatever you want, isn't it? Now, if anyone in the class tell me, is there anything that is shown there not a responsibility provided by user agent? If you are using
Forwarding.
Gmail, you will forwarding. Yes, you can do it. Why can't you? Have an option there. నీ యూజర్ ఏజెంట్ నీకు ఆప్షన్ ప్రొవైడ్ చేస్తుంది కదా. You receive a message, you click on the 3 dots, you'll have reply, forward, you have lot of options there.
కానీ ఫార్వర్డ్ కావాలంటే మళ్ళీ సర్వర్ వస్తుంది కదా సార్.
ఫార్వర్డ్ చేయడానికి ఆప్షన్ నీకు యూజర్ ఏజెంట్ ఇస్తుంది. ఫార్వర్డ్ చేసేటప్పుడు మెయిల్ ట్రాన్స్ఫర్ ఏజెంట్ వస్తుంది. ఫార్వర్డ్ చేసే ఆప్షన్ ఇచ్చేది యూజర్ ఏజెంట్. ఆప్షన్ ఈజ్ ప్రొవైడెడ్. దే ఆర్ ది సర్వీసెస్ ప్రొవైడెడ్, నాట్ ది హ్యాపనింగ్. హ్యాపనింగ్ ఇస్ నాట్, దట్ ఈస్ మెయిల్ ట్రాన్స్ఫర్ ఏజెంట్ అగైన్. రిప్లై అట్లా చూస్తే రిప్లై కూడా అంతే కదా మరి. ఈవెన్ రిప్లై ఇస్ ఆల్సో సేమ్ థింగ్. ఎంటీఏ షుడ్ కమ్ ఇంటూ పిక్చర్. ఓకే, సో దీస్ ఆర్ సర్వీసెస్. I have all this. ఇంకా ఉంటాయి చాలా. You can, these are the mostly used services, most commonly used services. Composing a message, reading a message, replying to a message, forwarding a message, and handling your mailbox, deleting them, checking unstar, star, all those things. They are handling your messages, handling your mailboxes. Okay, right. So these are the responsibilities of user agent. So now, how does an email look like? I have two diagrams there. The left diagram is your postal mail, inland letter or postcard. The right diagram is our email. Don't compare it. We already have a very good idea of email. Just don't even compare it with the postal mail. Directly go to the right side, right part of it. Don't look at the yellow part. Only look at the blue part. Right. What is in the blue part? From whom the author, the textbook I am following, Forozen. He is the person who is sending it to Sophia Figan. That person, Sophia Figan, is lady. She is the what do you call, like a maintenance person, kind of the person who takes care of the internet and all technical issues over there, right? So then the subject is about network and the date on which the mail is composed. Now there is a body of the message. You keep writing, dear sir, madam, greetings of the day, I am so and so person, I have so and so problem, this, that, and then thanks and regards, your name, right? Can you see the body of letter there? Very simple, right? Then, so these are all what we compose. But when you compose such a mail, when you do such a mail, this message, see the blue box actually has two parts, body and header. Can you see it? Now this entire thing is treated as a message. This entire thing is treated as a mail, and when you send this mail, a envelope, a header is added to it. What is in the header? Who is sending it? To whom it is intended. The rest is all, we can put it aside. The most important thing is sending the mail from the sender to the receiver. Why do we need sender's address there in the envelope? Why do we need sender's address in the envelope?
It has to move to his outbox.
Send box, excellent. First, it has to move to his outbox or that person's outbox. So first, we need sender's address. Then, why do we need receiver's address? Obviously, from that outbox, it should go to the inbox of the receiver. So these two things, if they are available, that's enough. So this message is added with a header, with an envelope. Only the envelope will contain only sender's address and the receiver's address, right? So now, even in my next chapter, which I'll discuss today, I'll even discuss about that mail IDs, that format, forozen@deanza.edu. Why is it? How is it? Why is that @ Why is that dot? Everything will be discussed. Okay, right. So now this is the format of email. Please draw this. I think you can easily draw this, but don't put lot of message in the body and don't fill a page in your examination. But draw this. This is very easy for you, and you can score marks with this. Done? Let's go. Now, how is this identity? How is the identity of the sender and the receiver in an email? It has two parts. The first part is client local. The second part is the domain to which this local part belongs to. For example, sandeep892@gmail.com. The first part and second part are always separated with @ symbol. It is the separator in between, right? So Sandeep892 is the local part that is used to identify me. @ domain name gmail.com is used to identify what?
Server.
The server. Okay, chalo. Now I have this question. Good, excellent answer. That is perfect answer. Now I am sending a message like this. Sandeep892@gmail.com is the sender to Manoj. Let us assume that Manoj has manoj@rediffmail.com. Now, first, from my user agent, the message goes to my outbox. From there,
MTA server will transfer to the other server.
MTA server will transfer it to
His
Reddit
domain name
mail
server.
inbox ID. This is like a courier service. This is like a courier service. Anybody can send anything to anyone. సో నేను జీమెయిల్ ఉంటే జీమెయిల్గా పంపిస్తాను రూల్ ఏం లేదు కదా. I can send it to any other mail ID, valid mail ID, right? So I just want to show you that there is a domain name. Domain name is the second part of it, right? So I have lot of domains if you want. Sandeep_ch@srecvarangal.ac.in. That is a different domain. I will also tell you what is srecvarangal.ac.in later. Later I'll tell you. I have another domain, Sandeep, ch.sandeep@sru.edu.in. I have another domain, ch.sandeep@sru.ac.in. See, I have 4 different IDs. The first part is all about me, Sandeep. The second part is all about domain. What do you mean by domain here? If @gmail.com, how many user IDs can there be under that domain? There can be a lot of user IDs, right? So from that, one of the user is identified, and that will be the recipient and that will be the sender. I mean, whichever is the local part will become the sender and the receiver. Are you understanding it? Right. Now, so let us now start with, this is user agent is completed. Now let us start with the requirement of today's email, MIME, multi-purpose internet mail extension. So before I discuss about this MIME, I think I forgot to put a slide in between there. Yesterday I was changing this slide, but I forgot. Yeah, before I talk about this MIME, multi-purpose internet mail extension. Actually, when email was introduced, only text used to get transmitted or sent from sender to receiver. Why? Because email, the architecture of email only used 7-bit ASCII, NVT ASCII. It's called Network Virtual Terminal ASCII, American Standard Code for Information Interchange. So it was only 7-bit ASCII. If you use only 7-bit ASCII, the number of combinations you'll have are 2^7 only. You cannot send images, you cannot send videos, you cannot send different things over on the internet. You cannot send symbols, some symbols. That was the restriction of the earlier email version. Then there came the invention called MIME, multi-purpose internet mail extension. So what is the role of MIME is, it plays its role in between a user agent and a mail transfer agent. From a user agent is our client side at the sender side, for example. First of all, when we compose a mail or when we do something, the first thing that comes into picture is user agent. The user agent allows us to do it. And then when you say send, for example, you are composing a mail and you are sending it. When you say send, generally what should happen? User agent should hand over the message or the data to the mail transfer agent client. Akka nundi server ki povali. But before it is handed to a mail transfer agent client, it is put to a algorithm or a protocol called MIME, multi-purpose internet mail extension. That will take a non-ASCII code. What is the difference between an ASCII code and a non-ASCII code? Simple. ASCII code, 7-bit ASCII code especially, 7-bit ASCII code will strictly accept each character converted into 7-bit representation format, isn't it? But if I have to send images, if I have to send too many things over the mail, I can send a video. I was sending a video yesterday. I can send a video. I can send audio file. I can send anything. Lot of things can be sent, right? So if I am sending everything over email, I cannot use a 7-bit ASCII format to convert that data into zeros and ones. ప్రతి దానికి 7-bit representation కావాలంటే దొరకదు కదా. Only 7 bits, right? 2^7 combinations, right? You will not get it. Done. So now somebody smartly has thought, I don't know how many of you will understand this. It's very simple to understand, but you should apply your brain to understand. So somebody has thought, why should we directly convert the message into 7-bit ASCII value? Why should we directly convert it? Let us just first convert the data into a non-ASCII code. It could be a Unicode, it could be any code, it could be any other code, into a non-ASCII code. What happens if you convert a data into non-ASCII code? It comes up as a series of zeros and ones. It could be 0, 0, 1, 0, 1, 1, 0, 1, dot, 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 dot. Now MIME will take this. It breaks into 777. E7 A ankondi. The representation of this 7 is A, but it need not be A when it was actually sent. Did you understand this? Did you understand the logic here? ఇక్కడ ఏ కోడ్ యూజ్ చేసినా సరే doesn't matter. it is converted into stream of zeros and ones. MIME will take a stream of zeros and ones. MIME will convert this into a 7-bit ASCII, 7-bit NVT ASCII. It's a type of conversion. MIME will convert it into 7-bit ASCII format. So this conversion, this interface in between will help the user to send anything using email, user agent. Without this, without the MIME, if you directly convert the message into 7-bit ASCII, not everything is possible to be sent as an email. Image cannot be sent, video cannot be sent, audio cannot be sent. They're all not represented using 7-bit ASCII. They're not 7-bit ASCII, right? 7-bit ASCII is only for, someone tell me, 7-bit ASCII is only for? 7-bit ASCII is only used to convert
Text.
text, which is numbers and alphabets or some special characters. That's it. That's it. Then how can I send a message? I mean, which includes a image, which includes a video. Now this is the part in between MIME, multi-purpose. You can see the name itself says multi-purpose internet mail extension to the actual mail. Now you can use this email in multi-purpose way, which means you can send text, you can send audio, you can send video, you can send graphics, you can send whatever you want. So MIME takes that non-ASCII data, zeros and ones, but non-ASCII, converts that non-ASCII data into its equivalent 7-bit ASCII. There is no rule, just break it into 7 bits. Whatever is the input, just break it into 7 bits. It's simple to understand. Then that 7-bit ASCII is given to MTA. కొత్తగా ఏం చేస్తలేదు, మధ్యలో కన్వర్షన్ చేస్తుంది అంతే. MIME is just helping in between the user agent and the mail transfer agent. Now mail transfer agent will transfer it to mail transfer server on the receiver side, let us assume. Then before it is given to the user agent on the receiver side, it is given to MIME first. MIME will convert back this 7-bit ASCII to non-ASCII code that was originally there, just like encryption decryption. Just like, for example, then that non-ASCII code is now given to the user agent, which now can be projected to you, image into image, audio into audio, video into video. That is how you are converting you are trying to send a non-ASCII representable data using an ASCII format. Initially non-ASCII representable data, but finally you are converting it into a ASCII format and sending it. Easy to send, right? So that's the use of MIME, multi-purpose internet mail extension. So what is it? It is like this. MIME comes in between as a header. In between the email header and the email body comes your MIME. We don't really write that MIME header. We only write the email header. We only write the email body. Header is also generated by itself. In terms of expression, yellow box is generated by itself, right? So we only write the email body. From that, a MIME header is constructed and an email header is constructed. So what is in the MIME header? It has 5 fields. The first field is MIME version. Currently, the version being used is 1.1. By default, it takes the version depending on the MIME you are using in your what is installed in your local system. It simply puts that version there, MIME version 1.1. Then content type and subtype. I don't know if I have the slide for it. Here it is. If the content type is text, if the content type is multi-part, message, image, video, audio, can you see it on the left side? So what is that? It defines whether the content being sent is text, whether it is image, whether it is audio, whether it is video, whether it is application. It defines what is being sent. Subtype, and then you have subtypes. In each type you have subtypes. Don't try to remember all this. Just have to name a few. The type can tell whether the mail being sent has the information, which is audio, which is video, which is image, which is text, etc. That's enough. Then content transfer encoding, the encoding type. What kind of encryption and decryption is used? It is defined there. The encoding type is defined there, right? Then content ID, a unique ID given to every message that is being sent. A unique ID is given by it. Then content description. So it gives a textual description of non-textual content. It says if there is a video in the image, it says a video. It says if there is an image in the message, it says image. Type defines a code which will tell whether it is an image, whether it is a video. Content description will give you a textual description. Video ante video and rasuntadi. Image ante image and rasuntadi. Why all these are needed? Why all these are needed? On the receiving side to
On the
convert.
converting.
Excellent. That's it. Simple, very simple. To convert and give it back to the user agent on the receiving side. These are the essential fields that a MIME will add as a header. Simple. MIME helps in converting non-ASCII, accepts non-ASCII data and converts it into 7-bit NVI ASCII data. NVI stands for Network Virtual Terminal. NVT, not NVI. Network Virtual Terminal. Right? So now, with this, now our email is perfect. We now know a user agent. We now know MIME that comes in between user agent and mail transfer agent. We need MIME. We now know the structure of email. So finally, we are left with two things, a mail transfer agent and a mail access agent. Let us understand what they are. Right, content transfer encoding, then comes your mail transfer agent. The actual mail transfer is done through MTAs, mail transfer agents. To send a mail, a system needs to have a client MTA. To receive a mail, a system needs to have a server MTA. That's it. Simple. Sending, client MTA, receiving, server MTA. Right? Then the formal protocol that defines mail transfer agent, client and server in the internet is SMTP, Simple Mail Transfer Protocol. That is the protocol that acts or that helps in the transfer of mail, that acts as a MTA, mail transfer agent. So how does this work? Very simple. A simple mail transfer protocol acts as a mail transfer agent. It can send, the first step is, what is the role of mail transfer agent? User agent, Karvata, the data is ready to be sent, right? Now it is given to MIME. After the MIME, the data is ready to be sent. SMTP will now play its role to send from client to the server. SMTP client to SMTP server. Sorry, mail transfer agent client to mail transfer agent server. Then from that mail server, again, it has to be sent to the receiver's inbox. First, na దగ్గర నుండి నా outbox లోకి, నా outbox నుంచి receiver's inbox. Again, who needs to do it? Mail transfer agent. So what is the protocol? SMTP, right? So SMTP works from sender to the first mail server to the second mail server until before receiver. That is the role of SMTP, right? So what is the role of SMTP or MTA? MTA will simply interact in the form of commands and responses. What is a command and response? I am ready to send a mail. Are you ready to receive it? Simple. Now user agent ikkada cheptundi, I have composed, there is a mail composed, I want to send it. Now the mail transfer agent should communicate with the server. I have a mail ready. Can you accept it? Will you accept it? Are you ready? Can we connect? Can we establish a connection? Right? So all this will happen when you compose a mail and click on send. What happens? You see something, you see some information. Sending and of you see that tab, small information there, sending. So what is happening when that sending is shown there to you? Actually, all this is happening. The mail transfer agent at the local site is communicating with the server. Then if the message is transferred to your outbox, then message sent and message vastadi. Always remember this. Whenever you send a message, you get a message. Sometimes you get a message saying that message sent, mail sent. And if you ask the receiver who is already connected to the internet, they will say, I haven't received it. Did you come across this situation? Instantly. Everyone has seen that kind of situation. Sender will send a message, mail, and the sender user agent will display a message saying that your message has been sent, but still the receiver will not receive it. Why? Because the sent message will come when the message is sent from your client side to the sent box. From there, it should be sent to receiver's inbox. From there, it should go to receiver, right? Okay, anyway, so the communication happens between the MTA client and server with respect in the form of commands and responses. MTA client will send a command, server will respond to it. What is a command? I have mail ready, composed. Okay, send it. It's a response. I'm sending video. Okay, send it. I want to terminate the connection. Okay, terminate it. Simple commands and responses. So ee madhyalo jarige communication anta this is taken care by SMTP, simple mail transfer protocol. Right? So how the command and response will be, or how the command will be? Command will be in the form of a keyword followed by a colon followed by argument. Here it is. What are those keywords and what are those arguments? The keyword first, if it wants to establish a communication with the server, SMTP. Now SMTP is sending a command. Okay, hello, HELO command. Hello followed by colon followed by the sender's host name. What is host name? IP address. Are you following?
Yes, sir.
Yeah, good. Right. So when you say send, I'm trying to tell you what happens when you say send. MTA client should establish a connection with MTA server, then send your message to the sent box, outbox. Okay. So it will now keep sending commands and server will respond either positively or negatively. So first it will send a command called hello, HELO. It will send the local host IP address. Then after identifying the IP address of the device that is sending it, then comes the mail ID of the sender, because I can send a mail from this laptop using Sandeep 892. I can send a message from my mail from my mobile using Sandeep 892 again, mail ID. Devices are different, the IP addresses are different, but the mail ID is same. Again, I can use this laptop to send a mail from sandeep892@gmail.com. I can use the same laptop to send a mail using sandeep_ch. IP address and mail address both are required. Are you understanding? Right? So first it sends the sender's host name, then it sends the sender's address, then it sends the receiver's address, and blah 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 blah. It keeps sending and receiving. It sends commands. It keeps receiving responses to it. Okay, right. The first three are very important commands and responses for you. Then, if the server has to reply, it can have a positive reply, it can have a positive intermediate reply, or it can have a negative reply. You can sometimes see the message cannot be sent, or sometimes you can see the mail ID is not found. Sometimes you see, a lot of negative replies coming back. Sometimes you see a positive reply coming back. The message has been sent. Right? Manakoche message veru, but the communication between MTA server and MTA client. Now, when the response is coming back, it is not a command, it's a number. It's a code. When MTA client is sending a command, it is a command. When MTA server is responding back, it is not a command, it is a code. You can see the codes there, some codes. Don't have to write all of them in the examination. 1 or 2 codes are enough. Right? 211, 214, 220, 221, 220 service ready. When the client asks, I want to establish a connection, maybe it will send a command back, service ready, 220. Okay, right. So this is how the MTA client and server will interact with each other. These are all the server responses. This slide and this slide are all the server responses. The previous slide is client commands. These are client commands. Right. So now I have put an example here. When giving names and mail IDs, who is sending a mail to whom, and I have shown you 3 phases. Connection establishment phase, where an MTA client establishes a connection with MTA server. How will they communicate? See the first command, hello. Can you see it? Hello. Right? So I have clearly written step by step how the connection is established, then how the mail is transferred from my local client to the server, to my sent box, to my outbox. How? What are the steps? What will the client send as a command? What will the server respond as a code? I have clearly given them. Once the mail is transferred, how the connection is terminated between the client and the server. 3 steps. SMTP protocol has 3 steps. The connection establishment between the mail transfer agent and the mail transfer agent client server. Then the mail transfer from the client to server. Then connection termination between the client and server. With an example, with the names I have given you there. The black things are the commands, right? And the pink things are the responses. You can see it here from the beginning. Pink things are responses, black things are commands. Black things are sent from client to server, pink data comes back from server to client. Try to go through this and try to understand. Don't write this in the examination, just for your understanding. This example is only for your understanding. Right. So that's about mail transfer agent. So the final component is mail access agent. The first and second stages of mail delivery use SMTP from my local host, local computer to my outbox, from my outbox to recipient's inbox. ఈ రెండు ప్లేసెస్లలో I'll use SMTP or SMTP is used. Mail transfer agent is used, simply speaking. But from there, it should be a pull based. So what should be used there? Mail access agent is required. On the receiver side, mail access agent is required to pull the data from the server to my inbox or to my local host, to my local device, right? So SMTP is not involved in the third stage because SMTP is a push protocol. MTA is a push protocol. MTA is a push action. MAA is a pull based. It pushes a message from client to server. The third stage needs a pull protocol. The client must pull messages from the server. This stage uses MAA, mail access agent. Right. Currently, 2 message access protocols are available. They are called as POP, Post Office Protocol, which is really good, easy and interesting. POP version 3, POP 3, Post Office Protocol version 3, and then IMAP 4, Internet Mail Access Protocol version 4, IMAP 4. So both of them, I'm not going to discuss them separately because the lucky part of email is we just have to draw good diagrams. Explain in your own words with 5 or 6 lines under it. That's enough, right? So now the first 2 parts, can you see what is the protocol used from the local client to my sent box, from my sent box to receiver's inbox? What is the protocol used on the top? SMTP. But on the last side, from the inbox of the receiver to receiver's local device, it should be a pull protocol. So there are 2 protocols. Either you can use POP 3 or IMAP 4, Post Office Protocol or Internet Mail Access Protocol. So how do those 2 protocols work? They are more or less the same protocols. This is how they work. Ee diagram kuda meer exam lo giyalekapothe nenu em cheyalenappa, I can't do anything. Nenu em chesta ippudu chudandi, pull based protocol, how it works. I'll first use user agent. I'll open Gmail. Is that correct? After opening Gmail, what is the first thing I'll do?
Username, password.
Username akkada chudu agane unnada vere on rasunadu chudandi. Look at the first step from client to server. What are you giving? Username. First you give username, it validates username, then it will ask you for a password, isn't it? Enter a mail antadi, mail ID enter chestaru, enter kottangane mala password, enter your password ani vastadi. Validates username, okay, then you will enter a password, validate password. 4 steps are finished. Please draw this diagram, right? See, it's very complicated diagram, okay? Right. So then password is asked and password is confirmed. Then what happens? You will not request, user is not requesting it. Your mail access agent is doing all this, remember. So your POP protocol or IMAP protocol is doing this inside, internally. It will send a command called a list. How many of you have attended OS lab? What is the use of command ls?
It will list all items.
It will list all the files. It will list all the files. No, it will only list. It will not give you description of each file. It will only, it will not show you what is inside each file. It will only give you the names of the files, remember. So when a list is sent, see what is coming back, the email numbers and their sizes. Then it will say retrieve. You click on the first mail. మొత్తం ఒక inbox వస్తుంది మనకు అక్కడ. మీరు ఏ మెయిల్ మీద క్లిక్ చేస్తే then it sends a command. Your mail access agent, Post Office Protocol or IMAP will send a command to the server. Retrieve this particular mail to me. From the list you have given, user is asking me this mail, so retrieve this mail. So it will give that mail. See, retrieve 1 means first mail. Give email 1, ... Retrieve nth mail, give nth mail. It is pulling. POP is pulling. Did you understand this simple diagram at least?
Yes, sir.
Yeah, simple, very
Yes,
simple.
sir.
Please, yeah, simple. So if IMAP and POP is asked, you have to answer it because draw this diagram first. Though there is SMTP in it, you have to show it. You have to SMTP adigina, SMTP, POP, IMAP chupiyali. Even if POP, IMAP adigina sare, this diagram you have to show it with SMTP and POP and IMAP so that you understand where SMTP is used and where POP and IMAP are used, or IMAP are used. If I get to know that you know where actually they are being used, that's enough for me. I'll have a lot of idea in my brain that this person knows what exactly this person is doing here. Then draw this diagram. This diagram, everybody will draw it easily. Done? Right. So explain it in your own words. The first diagram, you have to explain about 10 to 15 lines. This diagram, you explain about 10 to 15 lines. That should be more than enough for you people. Right? So that's your email. 3 components of email: user agent, mail transfer agent, mail access agent. As an example protocol, or a good versatile protocol that is used as mail transfer agent is SMTP, simple mail transfer protocol. Then as an example of pull based protocol, mail access agent, we have discussed 2, POP and IMAP. Both are same, almost same. The version, there are minor changes. There are small changes from POP to IMAP, but don't worry about what it is. You can just say that both are almost same. Okay, right. Then the last topic of this chapter, file transfer. Good. We are in time. This is really nice. We can easily finish one more chapter in this unit today. So let's talk about file transfer now. Transferring files from one computer to another computer is one of the most common tasks expected from a networking or an internet working environment. Files to be transferred from one computer to the other computer. As a matter of fact, the greatest volume of data exchange on the internet today is due to file transfer. Greatest volume is due to file transfer. Hi, hello, how are you? And message because I want to put the message on it. Does it really consume space? No. The other day, I wanted to transfer a video to one of my friends. It was about 220 MB. Look at a simple file I am transferring without any message, without any text, anything in it. Just a simple file, but it is 220 MB, right? Any line of text రాస్తే 220 MB కావాలి. ఎలక్ట్రిసిటీ రేపు పొద్దున దాకా రాసినా కూడా కాదు అది. Right? So that's what. As a matter of fact, the greatest volume of data exchange on the internet today is file transfer. File transfer protocol. Again, I'll not go very deeply into it. Just like how I dealt with SMTP and POP, it will be the same thing, and you should easily understand what FTP is. Done? So let's go with FTP. FTP uses the services of TCP, Transmission Control Protocol. It needs 2 TCP connections. Generally, when we talked about TCP, you remember there is only one connection established. When we talked about SCTP, gurtunda? Stream Control Transmission Protocol, there can be n streams at the same time. Anyway, simply it needs 2 TCP connections, and the port number is also fixed. Port numbers are used at the transport layer. The port numbers for FTP connection are also fixed. The well-known port, there are 3 types of ports, you remember? Well-known port, registered port, dynamic ports, dynamic port numbers. Well-known port numbers. The well-known port 21 is used for control connection, and a well-known port 20 is used for data connection. Now I understood that there are 2 connections. 2 TCP connections are used by FTP between client and server, sender and receiver. 2 FTP connections or 2 TCP connections. One connection uses port 21. One connection uses port number 20. The port number 21 is used for control connection. I'll show you what is control connection. In my next slide, I'll show you. Next 1 or 2 slides, I'll show you. Port number 20 is used for data connection. Always remember, control is different and data is different. Data is the actual data being transmitted. Control is how to transmit this data, when to transmit this data, the control information of this data, the controlling information of this data. So similarly, when file transfer happens, there needs to be 2 connections to be established between client and server. One is called control connection. The second one is called data connection. Control connection uses port 21. They are well-known ports. Well-known ports, remember, for objective, second with objective. I may ask or may not ask. The port number 21, well-known port number 21 is used to establish a control connection. And port number 20, well-known port number 20 is used for a data connection, for established data connection. Right. So file transfer protocol. The figure, next slide, I'll show you the next slide, shows the basic model of FTP. The client has 3 components called user interface, client control process, and the client data transfer process. I'll show you in the diagram and I'll explain you in the diagram. User interface, client control process, client data transfer process. Why? Because we need two connections, right? Control connection, data connection. So you'll see client control process, client data transfer process. The server has only two components called server control process and server data connection process. User interface also less server key, because you are transferring from this side. We only need user interface. There it is only receiving it, right? The control connection is established between the control processes. The data connection is made between the data transfer processes. So I have two processes. When I said there are two port numbers, there itself you should understand. Every process will have a port number associated with it. Transport layer starting with anything, right? So I'll have two processes, a control process and a data transfer process, right? Then the control connection remains connected during the entire interactive FTP session. So once a control connection is made, it is on. Entire FTP session, it is on. But the data connection is opened and closed for each file transferred. So before a file is transferred, data connection is established, file is transferred, closed. Again, the next file, control connection stays as it is, on. Again, when the next data file has to be transmitted, the data connection gets opened, file transmitted, data connection gets closed. Right? So this is the simple working procedure of FTP. So here it is, your diagram. So on the user side, on the sender side, client side, from the memory, that left side box is the hard disk from the memory. From the memory, data should be transmitted. So before that, from the user side, there are three components: user interface, control process, data transfer process. Again, why do we need user interface? To access. Why did we need user agent in mail? To access the email. To actually do anything, we first need user agent. Similarly, we first need user interface here. Then a control process and a control process of client and server get connected. Data transfer process on the client side, data transfer process on the server side get connected. I can even go deeper than this and show you how the control process and client and server get connected and all that, but not here. This happens in a subject called network programming. The connection establishment, what are the commands sent, what program is written, all that. This happens in a subject called network programming. There you will come across all those connections and all. That's why I'm not giving you more deeper insight of all this. Then a connection is established between data transfer process of client and data transfer process of server. Simple. Connection between control process is always active. Connection between data transfer process is opened and closed for every file transmitted. File received on the server is stored in the hard disk. Last. Done? That is how a simple FTP works. Very simple, right? Good. So this is how the connection is shown in a simple diagram again, without all that, between the control process. A connection between the control process. Then a connection between the data transfer process. Data is transferred. So three good diagrams. First, explain what FTP is, what are the components of an FTP. Then explain the overall diagram, a simple diagram of simple diagram representation of FTP, control and data transfer process. Then a simple control process data exchange control information between two control processes of client and server. Then the data transfer that happens between data transfer processes of client and server. And then I have an example put for you to understand how FTP transfer happens, including the commands and the responses. FTP client to FTP server, commands and responses. Right? So that's the end of FTP. We are not done with 5th unit yet. We still have one. Yes, please.
Sir, I had a doubt on mail.
Can you
mail
please
part.
go ahead? Please.
Sir, if you use two different domains, for example, I use a Gmail domain.
Okay.
And one of my friends uses a SRU domain.
SRU.
So how this from one mail server, it should be sent to the other mail server, right?
I'm coming there. That is my next chapter. Because
Yeah,
now,
okay.
now your Gmail domain is different because you are using a different user agent, which is Gmail. You type actually to send a mail, you type www.gmail.com. But it has to be sent to a server, which is a different domain again. Isn't it?
Yes, sir.
అంటే అది కూడా ఒక డివైసే కదా, సర్వర్ కూడా ఒక డివైసే కదా, నువ్వు ఎక్కడ నుంచి పంపిస్తావు? యా, సర్వర్ ఈజ్ ఎ డివైస్. దెన్ దట్ డివైస్ విల్ హ్యావ్ ఏ
its own
What address?
IP address.
IP
IP
address.
address.
If I can identify the IP address, can I send the message to that specific device server?
Yes, sir.
Yes, we will see. Let's see now. Let's see if I can identify that server now. So now the last chapter, of course, not the last chapter. There are 2 or 3 small topics which I am leaving them to you as self-study topics because they are simple. I have shared them in your Canvas slides. I have shared in the Canvas. And one more important announcement. Let me pause. Let me pause the recording. Right. So I'm sharing you the screen now again. The next chapter. Right. So here is the chapter again. Domain names DNS. DNS. It's in short called as DNS. Domain name system. Okay. Right. Here is your question. I think it can be answered. We will see now. Okay. That's the first slide I wanted to put actually after that email. So now, what is this relationship? We will see how exactly it works. Now, user is trying to send a mail. On the user side, user agent has started. What will the user agent send first? A connection establishment command and then a IP address of the local device which is sending the mail, and then the sender's email address, and then the receiver's email address, isn't it? Right. So let us just assume the receiver's email address is given there from user. Can you see from the top? Receiver's email address is
Yes,
a
sir.
person, some person, and the domain is @wonderful.com, just like your gmail.com, just like your gmail.com, your friend's domain, SRU domain, whatever it is. A person @wonderful.com is the recipient's mail ID. Now that is put to whom? Mail transfer agent. What is the protocol that works at mail transfer agent? SMTP.
SMTP.
Yeah, simple mail transfer protocol, right? So now, so SMTP client has received it. SMTP client has received it, but SMTP client cannot send a person @wonderful.com to SMTP server. That is wrong. That is wrong. Where should the mail go? My first question is, where should the mail go? First, from my local computer to my outbox. Okay. From my outbox to
Receiver's inbox.
receiver's inbox. What is receiver's inbox? The server of the domain he is using. Is that correct? అక్కడ నుంచి పుల్ చేసుకుంటారు కదా, అక్కడ నుంచి లాగిన్ అయినప్పుడు వస్తాయి ఆయనకు, అదేనా? కరెక్ట్?
Yes, sir.
Is that correct? Yes.
Yes,
Right.
sir.
So now, how do you identify that server? With the domain. With the domain. Is that correct? How do you identify my outbox? With the domain. Sender's mail ID లో నా డొమైన్ ఉంది కదా.
Yes, sir.
Sender's mail, yeah, good. అట్లాగే I'll not take 2, I'll only take one of them. Receiver's mail ID also has the receiver's domain.
Yes.
Yes. Now look at what SMTP is doing. It sends the domain, the domain of the receiver. I'm only taking receiver here. It will send the sender's domain also. It will now send the receiver's domain. Look at it. It has broken that. A person is the local. @ is the separator. Right side will be domain. I have told you that there are 2 parts in it, local and domain. Right. So now look at it. It has broken into 2 pieces. It has only taken the domain. What is it? Wonderful.com. Wonderful.com. SMTP is sending something. Wonderful.com to whom? This topic today, now topic. What is it? DNS, the domain name system. It sends to the local DNS client. If the local DNS client has some information, I'll tell you what it is, what is coming back later after this. If the local DNS client has the information that SMTP is looking for, it will send it back. Or it will send it to another DNS client or server, whatever it is. For somehow, somewhere, for wonderful.com, there will be a reply found. What is that reply? We will see. That reply comes back. Look at what is coming back.
Address of the.
What is that IP address? IP address of wonderful.com server. So where will the data go to? Network layer పోయినప్పుడు 2 అడ్రస్ లో ఏముంటది అప్పుడు?
Receiver.
ఈ IP address అక్కడ ఉంటుంది. That is how the data goes to the server. wonderful.com server కి పోయి అక్కడ ఆగుతుంది, అక్కడే ఉంటుంది, అక్కడ నుండి పోదు ఇంకా. Now what should happen after that? That person, a person అనే person ఏం చేయాలి? He should use his own user interface, user agent. ఆయన wonderful.com అయితే wonderful.com, లేదా ఆయన Gmail అయితే Gmail. He will log in, he will get connected to his server using what? Mail access agent. Mail access agent will pull the mail from there, from that server. Did you get it? How exactly it went to that other domain?
Yes, sir.
Yes. Who is helping it? DNS. That is our topic now. DNS maps. DNS maps a name to an IP address, or an IP address to a name. Why? Why? www.enadu.net, easy to remember. www.srecvarangal.ac.in, easy to remember. Amazon.com, easy to remember. sru.edu.in, easy to remember. Inka, you have hundreds of website URLs in your brain. What if I ask you to remember the IP address of each of them? And whenever you want to access srecvarangal.ac.in, there is no domain name, there is no name. You should type IP address. Remember that IP address and type it. If you want to access enadu.net, no name lediga. You have to remember the IP address of enadu server and type that IP address and get your enadu paper. Come on now, can we do this? How many IP addresses? No, we cannot. We cannot remember those many IP addresses. That's why we have a concept here called DNS, the domain name system. The domain name system helps in mapping an IP address with a name, or name with an IP address. Even if you type an IP address and say enter on the bar there, you will finally, when the server is found, you'll get name instead of IP address there, because the DNS will take care of all this. Right? So wantedly I have put this slide as the beginner. This is not DNS beginning actually. Wantedly I have put this slide as the first slide of DNS because I wanted to correlate your previous chapter to this chapter here, how exactly the other domain is accessed. And luckily one of my students directly asked me that question before I even started explaining all this. Good, that's really good. Okay, so this is the role of DNS. So now let's start with the namespace, because I told you an IP address is mapped with a name, and name is the one we are remembering, right? So let us look at what are those names and how exactly are those managed, and what is that namespace. To be unambiguous, the names assigned to machines, because they are servers, they are machines, they have IP addresses. We don't want IP addresses, we want names to be unambiguous. We don't want any confusion. The names assigned to machines must be carefully selected from a namespace. See how exactly the construction happens. Manam anukunnanta easy game undadu. Look how intelligently the construction of the names happen. I'll show you how exactly the construction goes down and goes up as I go on. Carefully selected from a namespace with complete control over the binding. There should be complete control over the binding between the names and IP addresses. They should be completely binded. Specific IP address to a specific name. No two different names can have the same IP address, right? Whenever you get these messages, before I go into the actual topic, I want to say a small general topic. Whenever you get these messages, you see that a lot of people forward such messages. A mobile phone for 1 rupee. Amazon is giving one mobile phone for 1 rupee. A smartphone for 2 rupees. This is for 10 rupees. You forward this to 5 groups, 10 groups, and a lot of people do forward it. Did we ever come across such foolish messages being forwarded in the group? Did we ever come across such foolish messages forwarded in the group?
Yes, sir.
Yes. So now I'll tell you, as I go on, I'll show you how to identify whether it is a genuine message that is from Amazon, or is it a fake message that is created just to get circulated over the internet for some reason, right? We will see. With this domain namespace, now we should understand. Finally, we should get to a conclusion. Okay, right. There are two types of namespaces. They are called as flat namespace, hierarchical namespace. The name itself says flat, just one name. Hierarchical namespace. Hierarchical means generations, one after the other. There will be a hierarchy of names, right? Then we will see what they are. The domain namespace, right? So to understand a flat namespace, generally we don't use a flat namespace. There is never a flat namespace. But hierarchical namespaces are what we generally use. SREC Warangal dot AC dot in is a hierarchical name. It has 3 parts in it. I'll explain you what those parts are later, not now. Because it has 3 parts in it. SREC Warangal dot AC dot in is having 3 parts in it. This is a hierarchical name, not a simple name. SRU.edu.in, hierarchical. Amazon, not hierarchical. Amazon.com, hierarchical again. .com, extension, hierarchical, that's it. It has two namespaces, right? So that is a hierarchical namespace. Flat namespace will only have one, which is never used, which we don't really use, we never come across. Then let us look at the domain namespace. That is a namespace. Flat namespace, hierarchical namespace. Let us look at the DNS, domain namespace now. To have a hierarchical namespace, a domain namespace was designed. In this design, the names are defined in an inverted tree structure. I'll show you that tree structure. They are defined in an inverted tree structure with the root at the top. The root is at the top. Remember this. Now you have to answer this question after I go, after a couple of slides, you have to answer. The root is at the top. The tree can only have 128 levels from level 0 to level 127. How many levels I have here in srecwarangal.ac.in?
3.
3, that's it, as simple as that. It is an inverted tree structure. Inverted tree means reverse. Reverse. If I say reverse, should I come from this side? No, this is the last one. So I should come from this side. Is this reverse or is this reverse? No one confuse avagandi. You say srecwarangal.ac.in and reverse. In AC srec warangal and reverse.
In AC,
Right. So what is the structure there? I have told you. Inverted tree structure. Inverted means it should be in first, AC, then SREC. Do you know what they are actually? In means India. Under India, the tree is India now. Under India, in the namespace. Under India, there can be a lot of other domains. In that, there is one domain called AC, academics. There is another domain called edu, sru.edu.in. Now compare this, you will understand it. sru.edu.in. In and in are same. So this is the root. This is the root. Under this in, I have 2. What is? One is AC, one is edu.
Yeah.
Yeah, this is academics, this is education. Right? Then under academics, there can be SREC Warangal, there can be SHITS Warangal, there can be, I don't know if they have used the same hierarchy. If they have used the same hierarchy, there can be under academics, there can be a lot of other domains. Similarly, under India, there is another domain called EDU, education. Under education, I have another domain called SRU. This is my domain, our domain, sorry, SRU domain, right? So this is 3 levels. So how many levels can we have in this inverted tree structure? 128 levels. We generally don't go beyond 4 or 5. That is the maximum we go, isn't it? But we are allowed to have until 128 levels, 0 to 127. We can have this dot until 128. So this is how your domain tree, inverted domain tree structure looks like. The top is the root domain for the entire world. Root domain for the entire world. Under that, I have arpa.com, .edu, .org, .ad, .zw. Again, under ARPA, I have 3 domains. Under each domain, there can be subdomains again. So if I have about 5 such subdomains, my domain's name will be with how many dots? 4 dots, 5 names. Are you understanding this? If I have 5 such circles, how many such words will I have in my website address? అక్కడ ఉన్న బ్లాక్ పింక్ గ్రీన్ సర్కిల్స్ అన్ని కలిపి ఒక 5 ఉన్నాయి అనుకుందాం. ఒక సైడ్ పోతే నేను ఒక ట్రావర్స్ చేస్తే ఐ హావ్ ట్రావర్స్ ది ట్రీ ఇన్ వన్ డైరెక్షన్. ఐ హావ్ కమ్ అక్రాస్ 5. హౌ మెనీ నేమ్స్ విల్ ఐ హ్యావ్? నేమ్స్ 5 names. How many dots? 4 dots.
4 dots.
Yeah, that's it. That's what you should understand. So this is how a DNS nomenclature is represented in the form of a inverted tree structure. We'll go even bit deeply, don't worry. So this is how you should understand now. Inverted tree structure. There is a name here, challenger.atc.fhda.edu. So what is the last leaf? If you have a name called challenger.atc.fhda.edu, at the bottom, right? So now when you look at it, the challenger is the last one, then comes your ATC, then comes your FHDA, then comes your EDU, then comes the root for the entire world DNS, right? So now exactly the same thing. Under the root, there is a domain called IN. Under the domain, one of the domains, there is a domain called AC. Under AC, there are a lot of domains. Under that, there is one of the domain called SREC Warangal. Right? Don't have to write that example. Write our own example. srecwarangal.ac.in. In will be first root రాయండి, తర్వాత in inverted కదా, తర్వాత in, తర్వాత AC, తర్వాత SREC Warangal. Last will be SREC Warangal. Okay? Right. Now, whenever you get these fake messages, like 1 rupee phone, 2 rupee cooker, or all that, whatever it is, look at the DNS, look at the name, look at the URL, simply speaking, uniform resource locator, https : / whatever it is. If it is, for example, say Amazon is paying you, www. ఏముండాలి చెప్పండి first. www. తర్వాత ఏముండాలి? Amazon ఉండాలి. amazon.com // పోవాలి. If it is a sub-product of Amazon, it should be in Amazon DNS. Look at those URLs you receive to be forwarded, to be, those fake URLs. They will start with en.amazon.com / at.amazon.com / అంటే en at అనే డొమైన్ కింద అమెజాన్ ఉందా? అమెజాన్ itself is a domain, right? What is it, en and at? They're all, someone has created that fake, and they make you see. If I have en as a domain, under that I can have Amazon as a domain. That is different again. That is not your actual Amazon product, or that is not your actual Amazon URL. You get directed to some other website. Did you get it?
Yes, sir.
Amazon.com is mapped with a URL, so is mapped with an IP address. en.amazon.com will be different IP address, not your Amazon, obvious. So check that. Simple procedure to identify whether it is a fake message or the original message that to be transferred or that to be used or forwarded. Okay, it should start with the actual domain, not with some stupid domain, and then extension should not be your company. The company itself should be the first domain. Okay. Then there are two types of domains. They are called as fully qualified domain name, partially qualified domain name, right? If I open a web browser and simply type without even www, I'll simply type gmail.com. Will I get my home page? Yes. Yes, I'll get it. But this is called as a partially qualified domain name. I don't even have www. I don't even have HTTP. Of course, sorry, HTTP in pakka bitna, sorry, at least. I don't even have www in front of it. Right? So, fully qualified domain name will give you the complete domain name, which is mapped with the IP address in the DNS. సగమే ఇచ్చినాం అనుకో, సగం అది దొరకబట్టుకోవడానికి ట్రై చేస్తుంది. Such domain names are called PQDNs, partially qualified domain names. Fully qualified domain name is the name that you exactly give, which is actually present in the DNS server, which is mapped to an IP address and exactly present in the DNS server. Adhe nu type cheste fully qualified. If you type half of it or a part of it, then it becomes partially qualified domain name. Though you give a partially qualified domain name, most of the times the DNS server will try to identify what you are looking for and give you the right website. Sometimes it fails and gives you the wrong website. Sometimes it fails and doesn't even locate any IP, and it will give you an error message, website not found. Okay, so that's about FQDN and PQDN. What time is it? Good, nice. We are on time. Right. So I'm just trying to give you the domains in root in SREC Warangal. So you can see there from the root, there is a domain called .com. There is a domain called .edu. Now that .edu itself is a big domain. .com itself is a big domain. Again under .com, you have a subdomain. Again under you have edu, you have subdomains. SRU is one of those subdomains in edu. SREC or eNadu or your Amazon is one of those subdomains under .com. So a domain can be hierarchical and you can have a subdomain within a domain. You can have domains inside domains, and inner domains are called as subdomains. Is that clear? Now, which one is a subdomain in this? If I take this example, sru.edu.in, what is a subdomain in this? Only this. Don't even worry about root. Only these three. What is a subdomain in this? What is the topmost domain? In. Then edu becomes a subdomain. Under edu, there is a subdomain called SRU. They are also domains. Are you understanding or not?
Yes, sir.
Yes, sir.
Done. Then how these namespaces are distributed. Now we understood what a namespace is, how a namespace is given, or how it actually works out, how it is mapped, or what will be the importance of DNS. How this namespace is distributed. The information contained in the DNS, domain namespace, must be stored. However, it is very inefficient and also unreliable to have this stored on a single computer. అందుకే దాన్ని ఇట్లా split చేసేసి. Some domain names will be stored at the lowest level of the hierarchy, some domain names at the next level, some domain names at the next level and next level and next level. Okay, right. In this section, we discuss the distribution of the domain namespace, how exactly it happens. So now the first server is the root server. Under root server, you'll have the next subdomain server, some ARPA server, edu server, .com server, .us server, .au server, .in server, India, .au is Australia, .com is common, .us is US server, specific to those countries. Okay, right. You'll have such subdomain server. Again, for example, under edu, SRU could be a server. We have a server, SRU domain server here. There is some FHDA server, DK server, McGraw-Hill server, Irwin server, right? So it keeps down in the hierarchy, just like what we discussed in the previous slides, right? So now, the location that a server has control over is called as zone. It's called as zone. And if a zone has a server, that server will be responsible for holding all the DNS names of that particular zone. If it is controlled by a server, it is called as a zone. And if you have a zone with a server, that server is responsible for holding information of all the DNS names of that particular zone. It has to. Under a zone, you can have a domain. Again, if a domain wants to know a DNS mapping, it can load it from the primary server. So the server at the zone is called the primary server. And the secondary server will not have any DNS mappings. Whenever it needs a DNS mapping, either it should request the primary server or it should download the information from the primary server. Download చేసుకొని ఇదన్నా అర్థం చేసుకొని పంపించచ్చు లేదా it can't do it, so it will put the request forward to primary server. Primary server will respond with the mapping, IP address and domain name. Okay, that's about zones and domains. See here, the primary server loads all the information from the disk file, whereas the secondary server loads the information from the primary server. When a secondary server downloads information from the primary, it is called zone transfer. From the zone, the data is being transferred, so it's called zone transfer. Now, we are going too deep in DNS, I know, but it's okay. You identify how much you want to write in the examination, right? So I have a class to continue exactly at 12. Manoj, can you quickly take screenshot of the participants right now? Log the meeting, please.
Okay.
Yeah. So there are 2 or 3 more slides after this. Just go through this. I have generic domains, I have country domains, inverse domains, while Manoj takes the screenshots. Generic domains are like, .com, all that, whereas country domains are like here, IN, US, AU, they are specific to countries. Inverse domains are mapping IP address to domain name. Generally, DNS means mapping domain name to IP address. Inverse domain name means mapping IP address. You type a IP address and say enter. It will map the domain name and give you the domain name. That is called inverse domain. Okay. Let's just go through them. This you can write a lot of information if DNS is asked, but you have to know how much to write for 10 marks. You should know how much to write for 10 marks. What is important? What should be written? What should be written? So I'll stop today's class with this.